Hi, this last lesson I hope should satisfy our curiosity and just tie up some of the loose ends we have from theme 2. So we're looking to finish off the booklet. By now, you should have had a go at the exam practice questions on page 22 of your theme 2 booklet and completed what's in a word on page 23. If you haven't done that, press pause now and go and have a go at those activities. If you have, let's go through some answers. The first question then is about seismic waves and how they pass through the Earth. Now this is all about interpreting the data that's there. So the seismic waves that don't pass through layer 3 are the S waves. You can see that the S waves stop at the bottom of layer 2 before they get into layer 3. The velocity goes to 0. The type of waves then that can't travel through a liquid are S waves. The reason they stop at the bottom of layer 2 as they go into layer 3 is that layer 3 is liquid. And finally, we can see from the seismograph that the waves with the lowest velocity, the ones that would arrive last at an earthquake monitoring station, are the L waves. Remember, don't fall into the Year 8 worksheet trap. Now, you were filling in these towards the start of your Theme 2 booklet, so you could use that as a bit of reference. Layer 2 is the mantle, the biggest part of the Earth. Layer 3 is what we call the outer core. This layer of liquid iron and nickel that surrounds the inner core. We've already talked a little bit about states of matter. The mantle is a solid. That's strictly true, but as we'll see perhaps later on in geology, that solid will deform. Layer 3, as we've already seen, is a liquid. Layer 1 then, the crust, we know is made of rock, principally silicate rocks. More about that in theme 3. And layer 4, the inner core, is actually also made of iron and nickel. So you can see that the outer 2 layers, layer 1 and 2, are rock. The inner 2 layers that make up the outer and inner core are made of iron and nickel. Question 2 then shows you some pictures taken on Mars, two very interesting rocks, and we can tell from these rocks that they were deposited in a moving current of water. If you look at rock X, we've got pebbles in there. Now to have pebbles of that size, of a couple of centimetres across, it's too big to be blown around by the wind. That must be moved by water. Not only that, those pebbles are rounded. Now to round pebbles off, they need to be bashing into each other, they're colliding with each other in a flow of water. And finally we can see in rock Y that we've got cross-lamination there. We know from the work you did earlier comparing Earth and Mars that cross-lamination can only be formed in a flow going in one direction. Okay, we should have completed as geological experts what's in a word. Let's just quickly review those definitions. The core, this bit, is the innermost part of the Earth. These 2 layers made of iron and nickel. The central part is a solid lump of iron and nickel. Surrounding that, we've got a liquid layer of the same composition. The reason it's liquid is that the pressure is a bit lower in the outer core than it is in the inner core. The next word then is crater. This is an image of the moon. We can see we've got lots of craters in this area. These craters are these circular depressions caused by the impact of some type of meteorite. The crust then is another layer within the Earth. This time, though, the crust is this very, very thin outermost surface of the Earth. Compared to the rest of it, almost like the skin of a balloon. Our next word is mantle. The mantle fortunately forms the biggest part of the Earth, about 70% of the Earth's volume, and it's this layer of hot but solid rock beneath the crust and above the core. What happens in the mantle has a massive impact on what happens on the crust. We'll talk more about that in theme 7. The next word is the mare. These are the dark patches on the moon. They were originally thought to be seas. We now know that they're basaltic lava flows, which they're younger than the rest of the moon's surface, which is why they're darker. They haven't weathered, and they tend to be smoother as well, as the lava has cooled to form these relatively smooth surfaces. Seismic waves are vibrations that go through the Earth, created by earthquakes, but there's different types of vibrations that shake the Earth. They also give us really good information about the inside of the Earth. Our last word then is terrae, the same image of the moon. This time though, the terrae are these highland areas, the older bits of the Earth's crust. They tend to be lighter in colour as they've weathered a little bit more. They're very, very ancient features of the moon's surface, and as a result are pockmarked with lots and lots of impact craters. Okay, that brings us to the end of the activities we have for theme 2. The next job is to think about how we can bring all this together in an assessment. I'll tell you more about that next time.